All right, perfect. Welcome everybody. So today I have Ramon. I've got Ramon Garo and Abby Deras, and they are here to present a DFIR demo. So please take it away. Explain to us what everything you guys have prepared today.
Sure, fantastic. Thank you, Michael. So I'm Abby Deras and Ramon Garo, and today we're going to be talking about digital forensic and incident response. Next slide, please. So this is what we're going to be going over. Just introduce ourselves. We're going to have some basic terminology, define what the forensic and incident response process looks like, go into some artifacts, and then go into some hands-on tools that we use in our field. Next slide. So I am currently an IT security engineer at Qualcomm. I specialize in digital forensics, host-based forensics, e-discovery, insider threats, and internal investigations. I've been in this field for over 10 years now. My day-to-day jobs include data collection, data preservation, and analyzing that data or digital evidence in support of internal investigations, insider threats, and e-discovery. Ramon?
Hello, everyone. Yeah, as Abby said, my name is Ramon Garo. I am a manager for incident response analysts at IBM. I've been in the field for about 13 years, and basically what I do and what my team does is we conduct analysis. And myself, I also have a management function for the team, and with the entire goal being to analyze, investigate, and fully characterize cyber incidents.
Awesome. And before we dive in, just wanted to say that the views and information we're providing today is based on our experience and what we do, not necessarily reflect those of our employers. Great. So let's get started. Our talks tend to be very technical. There's a lot of terminology that's provided, and sometimes we may not be always able to define those terms as we're talking. So we wanted to provide some basic terms that we're going to be using throughout the presentation. This is not designed to be an exhaustive list, but just serves more of a reference. We're going to do our best to define the terms as they come up. Yet, if you do have any questions, just feel free to put them out there. So the key terms that you will need to know are forensic image, acquisition, and imaging. Those are pretty much the bread and butter, the standard in digital forensics. And we did include a photo of a write blocker for those who aren't familiar with what a write blocker is. It's this black unit. It's a hard disk controller, which is designed for gaining read-only access to computer hard drives without damaging their content. So without tampering with the evidence, right? We will go into deeper details about artifacts and so just in case, these slides will be provided for you to access later. Next slide, please. Awesome. So before we actually begin demonstrating these tools, it's good to have a foundation and context around what exactly is the digital forensic process. And it actually starts with identification and preservation. So the identification piece is identifying what actually we're collecting. Is that a mobile device? Is that a laptop? Is that a USB device? Where is it located and what type of case it is? The answers to those questions will define how the investigation goes and what we're actually going to be trying to find. The next part is preservation. And there, what we're trying to do is isolate the data from either deletion or destruction. Once that data has been isolated, we'll move on to the collection phase, which is where we'll actually download the data and move on to, like I said, saving the data for our review. Today's talk is going to focus on that examination and analysis phase, where we will just review the data and try to find some evidence throughout that data. Next slide, please.
So everything Abby covered was the DF part of the DFIR initialism. What we see here on the screen is the incident response lifecycle, so covering the IR part. Essentially, the multiple phases are, for example, the green block is preparation. So that encompasses everything that's done to prepare so that an organization can respond to an incident efficiently once it's already known to have occurred. That could be as simple as, making sure the incident responders have their tools ready to go, so you don't have to scramble to install tools or learn tools. It could also mean, having a call tree in place, so department heads know how to get in touch with people like the incident response team. The yellow block is detection and analysis. That's examples of that would be, you get an alert for suspicious activity on the system, and then all the subsequent analysis that goes into characterizing the activity that caused that alert, right? In many cases, the analysis part, it also matches up with the DF process that Abby mentioned on the previous slide. That red block encompasses containment, eradication, and recovery. The containment could be something like removing network connectivity from a server that's infected with malware or disabling a user whose credentials have been exposed to the internet. Eradication could be deleting malware files off a server, reformatting a server. And then recovery is, restoring a system to its known good backup. Finally, the blue block is post-incident activity, which is also frequently called lessons learned. That's stuff like presenting and information gathered during the incident response to help feed back into the earlier phases. And that's something that's important to know. You see those curved arrows here. It's because every phase, this is really a cyclical process, and every phase tends to feed into the phases both before and after. All right.
Awesome. So artifacts. Artifacts are pieces of data that are produced as a result of certain types of activity. This is where most DFIR analysts live, is we live in artifacts and we speak of artifacts. So if you can see in the chart here, whenever a user or an individual visits a website, there is an artifact that is created in the browser history. If anyone ever attaches a USB device to a machine, to a laptop, a computer, a desktop, an entry is created in the registry. And anytime a malware is actually downloaded or executed, you can see that a file is created on the file system, there's an event log, and then there's a prefetch entry showing that execution. Being an effective DFIR analyst requires good knowledge of these artifacts and the conditions that produce them, when to analyze them, and how to analyze them. And that feeds into, there are multiple artifacts, and adding those up together builds a case. And if you're able to find those multiple artifacts that consistently describe that activity, then you have a really good case, or evidence of something happening, as the title of the slide says. So next slide, please. Yeah, so there are a bunch of artifacts. This is a sample of the SANS poster of Windows Forensics Evidence of artifact poster. This is just a small snippet of that poster. This poster specifically shows some artifacts found in Windows. And yeah, it's just important to know that there are a lot of hundreds of different forensic artifacts. So, and don't worry, you don't need to know them all. This is why these resources exist. And I think every forensic examiner has this poster posted in their office. Cool.
There you go. There's mine right there.
Next slide, please.
Yeah.
Great. So now that we've outlined what artifacts are, ways, the ways we need to analyze them, one of our favorite tools, and one of the most commonly used tools, is called FTK Imager. It's actually a free tool that's used to create forensically sound images, and images are a bit by bit, sector by sector direct copy of a physical storage device. So that's what forensic examiners actually use to analyze their evidence. As I said, it's a great tool to get started in DFIR, and we're going to take a look at that tool in the second half of our presentation. Cool. Next slide. And this is just a sample of what FTK Imager looks like. So yeah, next slide, please.
So what we see here on this screen is a screenshot of a tool called Registry Explorer, which is another free tool. Actually, everything we're demoing in this presentation today is 100% free, and you all can go download it as soon as we're done. here. And essentially this tool is used to analyze, to first load up and then review the content inside the Windows registry hives, which are essentially these databases on Windows that maintain all sorts of kind of configuration settings related to the operating system and different applications. And so there's a wealth of information in the registry hives. So anyone that does digital forensics, it would serve them to be kind of well acquainted with the registry, you know, the relevance of different aspects of the registry and tools you can use to look into the registry. What we have on the screen now here is another tool, also free, called Win Prefetch View, which is published on the internet by in a website called Nearsoft. And essentially, what the prefetch is, it's an artifact on Windows that is meant to record the operation of programs, specifically in approximately the first 10 seconds. And the reason why that's useful is because it can give you a lot of information about the execution of different applications, including it can tell you the number of times applications executed, how many times in the past it's executed, all the different files that are loaded up. So it can be really useful for malware executions, for malware investigations, and helping you figure out activity in the past. Most other execution of evidence of execution artifacts only tell you like the last runtime or the first runtime. This one can tell you multiple runtimes. So it's really, really useful when you have that available to you.
Awesome. So one of the other tools that we're going to look into today is called Autopsy. Autopsy is a digital forensics platform used by examiners to investigate what happened on a computer. It's designed to be an end-to-end platform, and it's pretty cool because it comes with modules that are pretty much straight out of the box. Things like a keyword search, which indexes the data found in some files. So if you're looking for some relevant terms, you can go ahead and kind of add those into the module, and Autopsy will index that data and try to find any relevant hits. It also, another module that's really cool is, for example, the web history, which actually extracts any, web activity, bookmarks, and cookies from Firefox, Chrome, and IE. Cool. And with that said, I'm going to go ahead and take over from here. And we're going to dive deep into FTK imagery. So let me get started with that. Awesome. So hopefully you'll see my screen here. And so in this case, I have already loaded my evidence here. That's an EO1 image. And I was recently asked, where can I find some image files? There are some resources available, such as aboutdiffer.com. Magnet Forensics is going to have a CTF later on this year that will provide an image file for you to use and to play with. Also, I believe Belkasoft has their own for digital forensic CTF that you can use and actually practice on. So it's really easy to come across these image files. So once you have that image file, they're normally in what's called an EO1. That's a file type, an image file type. You can go ahead and just point FTK to it, navigate to where you want. In this case, I already loaded it up. This is my EO1 file. I'll have it on there, and then I'll go ahead and this is what happens. It'll load up here in this evidence tree. And you'll notice that there are 4 partitions. Partitions is just a way that the hard drive organizes the data. What we're interested is in what's called the active partition, could be, which is, and yes, I just recently loaded that. What you just saw was parsing the MFT, which is something examiners spend a lot of time doing, depending on what tool you're using, because of the way that hard drives organize data. That's really important if you want to dive deeper into forensics, digital forensics, or host-based forensics. Going back to this, we see our partition. I'm interested in this partition. When we drill down, it's here. You'll notice that there's a lot of files. There's this folder structure. We're actually interested in our users folder because that's going to have the most data. It's the user created data, and we're actually interested in this user right here, anti-rensic. If we dig in, we'll notice that another file structure, and there's a lot of useful information here. So if we look at the desktop, we'll notice that, hey, this user has this important JPEG that's kind of weird. Something named important. So that gets our spidey senses going. Then we'll look at this. There's another file. It's called "In order to ensure Resnick is treated properly." And this file is this image. I should provide a little bit more context. Was used in the autopsy CTF last year, where it's the case of the stolen puppy. Ramon, correct me if I'm wrong.
Yeah. It was the dog's name is Renzik, which is a play on forensic, and he was kidnapped by this anti-Renzik group. So obviously, this would have been like a suspect's laptop that was recovered, and they're trying to do analysis to see if they could find the dog. So clearly, we see files, talking about in order to ensure Renzik isn't treated properly. That sounds like a ransom note or something like that, right?
Right. And so that's something that, you're going to have to start thinking about. And we'll go into further details if you attend our second talk on what is different of what some of those skill sets look like. But yeah, that's one thing you would have to look at. The good thing about FTK going back is that it does provide a lot of like metadata. Metadata is simply data about data. When was this photo taken? Where was this photo taken? Or when was this document created? Where was it created? And here you can see, if we navigate up, you see, we're not really curious about
right here.
Okay, right here, right? You want to see the data, the date accessed, the date created, the date modified. Okay, so that's a really good thing to know. Another thing that's really great about, if we go back up here, one of the artifacts that I live in as a forensic examiner specializing in the insider threats, it's that like user created data. What did the users actually do? And one of my favorite artifacts is the ntuser.dat. As you notice, that FTK Imager kind of doesn't really parse it. So there are other tools that you can use to parse this information and actually review it. Now, keep in mind that the reason why we did this demo, and one of the reasons that drives us to this, is building your toolkit. No one tool is going to be able to do it all. So it's really important to know what a tool does, what it can do, and what limitations there are. Sometimes you're going to be working on the fly, and you're going to need to have access and knowledge to a variety of tools. In that instance, sometimes, for example, if FTK Imager can't do it, we're going to just mosey on to autopsy. As you can see, autopsy has the same exact structure. I'm sure if you can still see my screen, it has the folder structure here. And if we navigate to our partition here, over here, we can see our user folder, right? And if we drill down further into this anti-Resnick and we navigate to the desktop, we'll notice that, hey, here's this file. Oh, still look at this JPEG, still looks kind of wonky, right? And then we see that, hey, we have this document, right? You can look at the results tab, the file that it also provides you the metadata. If I navigate to text, it should be able to provide me the text, assuming this is a doc file. I know that's a lot of information, and I do want to give time so that we can dive into the other tools, but this is a really short preview of what autopsy can do. And like I said, we did the keyword hits. It parsed some of these email addresses, so we can see like .turner@turner.com. We have a couple of other random, a Gmail, like a 3D anti-resnick@gmail.com. That sounds like it might be interesting for our case. Cool. And I'll hand it over to Ramon to showcase.
Well, while you're still here, Abby, we still have a good amount of time. Something that would be useful for people to see is, like, for example, the ingest modules. So, I mean, if Abby scrolls up on that pane she's in, and then right clicks on the device E01, the device _ laptop.
All the way up here?
Yeah, right click it. Yeah, when you go to stay right there for a second. Yeah, so that's where you actually go to do the good stuff, the parsing that autopsy does. So if she clicks there, you'll get a menu where it shows you all the different ingest modules that Autopsy already has built in. And what you will see, for example, is you'll already see some that were checked off there. Yeah,
Yep,
like for example, the photo rec would be used if you want to recover files. Keyword search is going to be something we could show you really quickly here, because that's one of the cool things that people always have to do, right? And you see she put some different keywords that she wanted to look for: email addresses, Toro hack. Those are keyword lists that have different terms in there that are interesting for her based on the nature of the investigation. But to show you quickly, like the actual keyword search function. So if you close out of here, Abby, and then go to the keyword search, which is up there in the corner. If you want to do like a one-off keyword search all the way up in the corner, and then just put, Renzik, RENZIK, for example. And because she has that saved, it's going to actually save it, so she doesn't have to keep running it every time. Yeah, it'll run. Go ahead, let that run, and she'll see down in the corner, yeah, all of the different web history, all the different places where that term appears on the image. So that's really useful, because you might even get hits for deleted data, files that were deleted, but there's still remnants of it left on disk. So that's an extremely useful function for forensic analysis in general, when you're looking for data and don't necessarily know where it might reside on your evidence.
Absolutely. Yep. Good points. All right.
So let's jump in now to some of the other artifact-specific tools. All right, I'm sharing my screen. Okay, so you all can see FTK Imager, correct? Okay, Abby, you can see FTK Imager, correct?
I can see it, yep.
All right, so to go off of what Abby said, I also use FTK Imager. I loaded it, and what I did is I quickly mounted it. And what you see, that image, I mounted it. So now what appears is all these drives on my computer, actually. So when I go to, you see here, I have it there. If I go to, 1 second. So I actually have it there. I'm inside that same user, and I see the ntUser.dat, and that's the same artifact that Abby mentioned. So what I'm going to do is use that Registry Explorer tool I mentioned before, load Hive. And I already had gone there prior to the demo. So I see ntUser.dat, I open that, it takes a second. And what I can see here is I can now browse through that registry Hive for the particular user, the Renzik user. Registry Explorer is particularly useful because it has already bookmarks built in for locations that are known to be useful for forensic analysis of registry Hives. So one common one that we'll go into a lot, especially for the type of work Abby does on a regular basis, is the recent docs. This will show me, documents that were recently opened by the user. I can scroll through here, see lots of things, and boom, right there we see that same document that Abby, scrolled over on the both Autopsy and FTK Imager in order to ensure that Renzik is treated properly, and it has a date for when it was last opened. And much like Abby said, we should be able to see that same date in multiple artifacts. We would likely see that in the run MRU also, but here it shows here that was opened on November 5th, 2019, which was right around the time of the kidnapping, if I remember the scenario correctly, for the this particular case, the CTF exercise, so to speak. I could also, if I want to load up like another Hive, I'll go up to, let's see, Windows. This is where the system Hive lives, Windows config. Sorry, Windows System 32 config. And this is really just because I have this memorized from going here so often.
Oh yes, this is one of our favorites.
Yeah. And now I will go to system just because I want to see some information about the system. So now you see that the ntUser.dat, I'm going to minimize that, and instead I'll go to the system Hive. I'm looking at the bookmarks again. So for example, if I want to see all the services that are installed on this machine, because I'm looking for potential malware, I'm looking for anything they ran as a service that might be suspicious. And now I see here all these services. In this case, I know, this one service called Veracrypt. Where is it? Veracrypt, yeah, Veracrypt, which is a program you can use to encrypt files, to encrypt your entire system or make encrypted containers. And look, weird. That was set up a few days before that ransom note. So could that be something that the bad guys set up so they could hide their data within an encrypted container? That might be something interesting to investigate, right? We might want to try and recover that encrypted container and see if we could break into it to see what kind of relevant data might be in there, data that would not have otherwise been available for review if we didn't even know that VeraCrypt was running and they had encrypted containers there. So there's also obviously a ton you can do in registry, lots of analysis that takes place solely in there. We're only giving you a little taste, but that this is just to show you that there's lots of free tools. And the other reason, I mean, Autopsy is great because it puts everything in one place, but it is always good to know about tools that are specific to certain artifacts, because a lot of times the tools that are specific to certain artifacts go into more detail. They can do a little bit better of a job parsing those specific artifacts because that's their purpose built for that. So it's always good to know, just like Abby said before about building your toolkit, you always want to have multiple approaches to deal with a particular problem. So you don't want to rely just on Autopsy or just on FTK Imager. I want to be able to parse registry with a tool like Registry Explorer, and also RegRipper, which is a common one people use, or use like an NK script to parse a registry, for example. So that's Registry Explorer. Now we'll go into a different tool called Win Prefetch View, which was the Win Prefetch View, pardon. All right, so when I open Win Prefetch View, the first thing it does is it tries to load up the prefetch on my actual system, but I don't want to do that. I want to load up the prefetch on the mounted image that I mounted using FTK. So this is actually the prefetch of the kidnapper's machine. So I selected the location where it was mounted to and the prefetch directory, give it a few seconds, and now it does its thing. It's showing me all these different applications that there's a prefetch file for and the corresponding information. So remember earlier when I was on Registry Explorer, we were talking about this VeraCrypt tool. So now if I go down here and I scroll down, scroll down to the V's, I will see a bunch of VeraCrypt applications. VeraCrypt setup, that obviously sounds like something that they would have had to download it in order to install VeraCrypt. I see the last runtime was 1029, which is they installed, apparently they ran the setup for VeraCrypt at October 29th, 5:13, which if you go back here, very close. This is in military time, but that also says, 5:31, and this is 5:31. This is exactly what we mentioned. We have multiple artifacts that are lining up with the same information, prefetch and registry. If I see the actual execution for the VeraCrypt application, now this is what's really cool. You see multiple instances where it was run in the past. That information is difficult to get otherwise. Usually a lot of artifacts just give you the last time, which would be October 4th at 11:45, or they might give you the first, but it's hard to get the ones in between. And this is why, this particular artifact is really valuable, because you can get multiple and you can get a run count. I can see all the different, files that were loaded up when VeraCrypt was, within the first 10 seconds or so. We may not get lucky and the files we want are included in that 10 seconds, but sometimes you are, especially if it's malware, because things get loaded up automatically. So, again, this is just to reinforce that point where you want to have a good understanding of the different artifacts on the operating system you're analyzing, what they mean, how you can analyze them, and then how you can present that data. Because that strengthens your case when you have multiple lines of evidence that point to the same activity, and it makes it harder to refute, whatever conclusions you come to when you can arrive at that conclusion via multiple different artifacts.
Sorry, we are coming up on the 30-minute mark. Thank you.
So at this point, we can show you more features of the different tools we discussed, or we can open up the floor to questions if there are any questions at this point.
Yeah, Michael, are there any questions?
Yeah, sorry about that.
It's okay.
Zoom options. Yes, so we have some questions here. So let's see. Is there something becoming a big game changer in the DFIR scene?
Oh, something that's becoming a big game changer. I guess I would have to say the cloud, our cloud environment and cloud infrastructure, things that we need to look into, as well as current trends in the industry are, there's a lot of big talk about, hacking or data breaches and the increase in attacks specifically targeting industrial control systems, right? So right now that's a big hot topic of how can we protect those, right? And then with cloud is once we've all moved remote, right? That just kind of redefine how we do our work. How do we collect things over the wire, right? And building a cloud infrastructure is one way that we can look into that, but that also takes time. Ramon, if you have anything?
I do agree with a lot of with pretty much everything you said. The other thing that I see a lot more, especially in my job, is like application container technology, Docker, Kubernetes. That is definitely something that's new, and it's becoming important as far as to have an understanding of, because you have these containers, they run, they do their thing, and then the container turns off for whatever reason, everything's gone. So you need to understand how to approach that so that you can investigate it, understand where the relevant data is, and be able to understand how to acquire the data you need for an investigation before it all goes away because you inadvertently shut down the container, or something happens where you lose the data. If you kind of jump the gun as far as what you do to try to contain an incident, you could easily just kind of destroy all the evidence you need in order to perform your investigation. So that's also relevant, not just for the investigation piece, but just as a for using for forensic tools, because now there are a lot of forensic tools that are available as containers, so that it's actually pretty useful because it helps you get things running more easily. That's essentially how I started getting into learning containerization technology, because I started using tools that were available as containers. So it makes life a lot easier for setting things up rather than having to install everything and deal with the dependencies, all that stuff.
Right. It seemed like a fun, like a treasure hunt almost from the demo, looking for important things, and obviously with both of your experience, you kind of knew where to look. That great answers, great demo. So another question, what were some stepping stones that got you into DFIR? So like kind of how did that happen for you both?
Okay, I'll go first. Well, I mean, essentially I started, I was working kind of IT at the university I went to, and it was just simple stuff like, a machine got like some simple malware, and I'm doing my best to figure it out. And I have no idea what's going on, but, kind of figuring out little by little. It's like, okay, I think this is the malware process. Like, when did that file get there? I'm checking, when did it get created? I'm Googling, like, how do you figure out how malware got on the system, right? It's like, how do I do simple, DFIR tasks, and learning little by little. And it's one of those things, essentially, you show enough interest and a little bit of promise in a certain area, and you kind of annoy people enough with questions and kind of doing your best, eventually, people will, either take pity on you or figure out you might as well invest in someone and send them to training. And that helps a lot.
Absolutely. I'll take this one. I actually stumbled upon this. I lost my job way back when. I was actually a trained archaeologist, and we'll go into that later at our next talk. But I started off in consulting at the bottom of essentially the forensics lab. I started as the evidence technician, which doesn't really play with a lot of the actual cases, but I get exposed to all the hardware and the actual process of what goes into being running a forensics lab. And much like Ramon mentioned about pestering people and bugging people and asking questions, I leveraged that. I identified my core skills and how those could translate into a career in digital forensics. And then I got the bug, right? And I started asking those questions, started being curious, started running my own investigations, started learning those tools. And that's why we wanted to present this demo too, because all these tools are free and readily available for anybody who's interested in building their own project. I'm a big believer that you can run your own project at home and start from the bottom and develop a case and see what findings you come up with. What kind of stories can you tell? Same thing, like I said, archaeologists, they build a story based on the artifacts that they find, right? That's exactly what a forensic examiner is doing. So.
And I figured we'd throw in there, since we mentioned, multiple times that everything here is free. Just in case if anyone's wondering, it's like, yeah, those are free, but they probably don't use that, every day on their investigation. Nope, not true. FTK Imager I use on every case I ever run. Every case I run. Registry Explorer I use probably on every case. Autopsy I use much of the time, maybe not all the time. When prefetch view, I like it a lot. I don't get to use it that much, but that's because the technical reason for that is because I work more with server cases, and servers generally don't have prefetch enabled. But if I was, any case where I'm running where they do have prefetch, I'll probably use that because I like to see the same artifact with multiple tools to make sure they agree with each other. So, and at previous jobs where I wasn't working on servers that much, I did use when prefetch view anytime I had prefetch to analyze. So, I mean, they are legit tools. You can use them. You can use them side by side with the very expensive ncases and axioms and all that. And they do a great job. So I mean, there's no reason to ever think that you are limited in your ability to explore this field because you don't have access to an expensive lab or an expensive tool. You can run all these tools on your laptop. You can do a full investigation on your laptop. You may be limited by storage. It may take longer if you don't have that much memory, that much processor, but you can absolutely run the tools. You can absolutely practice with a CTF exercise, like Abby mentioned earlier, about DFIR. We'll provide a lot of these links in our next presentation, but you can download these small images for testing. That one that we were using for this demo was only 3.5 gigs, so it's not that big. And you can practice. You can do your keyword searches. You can run a timeline analysis. You can look at registry, all that stuff. There's no reason to think you're ever limited based on expenses of tools or hardware.
Perfect. Yeah, I definitely also want to kind of plug that too. So at 2:30, there will be another session. What is DFIR? And Ramon and Abigail will be there, and they'll have if you have more questions and everything. But thank you. Yeah, great answers. Definitely, there are a lot of specifically like Raspberry Pi projects that I myself have kind of looked into, and there's so many, like you said, you could start anywhere. Raspberry Pis are very cheap. There's so many things you can do. It's really great. And here's a question. So the device shown at the beginning of the presentation, can that access encrypted files?
No, they're probably talking about the Tableau.
Right.
Abby, I think they're talking about the write blocker.
The write blocker.
No.
Yeah. Go ahead.
Go ahead, Abby.
Oh, okay. It really depends on what the encryption is. So what we would do is just to access the drive, and then we would probably run a software solution in order to decrypt those hardware. So for example, we see BitLocker all the time. That's kind of standard. All we need is that BitLocker key. That really isn't designed to decrypt things. I mean, you could work with the name escapes me right now, but you would add another device that would decrypt the data or encrypt the data. So, and this is just all hardware. But like I said, Ncase, Ramon mentioned, I know that is an enterprise level solution, but I think FTK can do it as well. It'll let you know, hey, this device is encrypted. What do you want to do? And you'll need another way to decrypt that device. Ramon?
Yeah, there are some free ones also. So basically, I mean, just to reiterate what Abby said, that device we showed is specifically so that when you're imaging the evidence, the original evidence, you don't accidentally make any changes. You don't accidentally damage the data that's there. So that doesn't really have any relationship with encryption that's on the device or not. The encryption that may or may not be on the device, that's something you have to deal with after you already created an image, after you copy your bit for bit copy of it. And like Abby said, that's, if you have the decryption key, then you would use your software to decrypt it. Ncase, FTK can do it. I'm not sure about Axiom. I know there are some free tools on the Linux side that you can use to help deal with encryption, but that's kind of a separate step in the process. That black tool, the Tableau, that was a Tableau write blocker. That's for the collection phase. Doing the actual decryption, that's the next phase. That's like processing it and analyzing. So those occur at different points. Whether you have a write blocker or not, that doesn't really affect what you can or cannot do about encryption.
Perfect, thank you. And here's our last question. So what are some of the most difficult issues facing someone in digital forensics and incident response?
I think I mentioned mine, but Ramon.
What was yours again, Abby?
Mine is just that we're going remote, right? That's one thing, right? We're going remote and trying to do this data collection, right? The second thing I think we're seeing is that these hard drives are getting ridiculously large, right? And there's just no way that we can actually collect 1 terabyte of data, right? So
Yeah.
when we're running our investigations, it's now we have to think critically even, and we have to think, what are we actually doing? That's why now that identification piece is becoming even more important. What type of case are we looking at? We can't just go in and start collecting 1 terabyte of data. I mean, I think Western Digital said that they were looking to increase up to 40 terabytes of data within the next couple of years. It's just mind-boggling, right? That's just another challenge that we're facing in the industry.
Yeah. To Abby's point, I had to deal with a 12 terabyte drive once and search it. And I was like, oh, wow, what am I going to do with this drive? It's going to sit there forever. For like 2 weeks, it was there indexed in the drive. And then somebody else on my team had like a 24 terabyte drive, and that was like a month or something like that just to sit there with that thing. So Abby was giving you, really good, and that's a very common, I want to say complaint, but challenge that people in the DFIR, it is a complaint, but it's a challenge, right? The people in the DFIR community, just growing data sizes. So I'll give you one, but more on the process side, the people side, which is, especially for newer analysts, newer investigators, is just how to approach their investigation. There's just so much data. There's so much you could do. It's like, how do you focus yourself to start arriving at answers quickly and not just spin your wheels and get stuck, and then it's 4 days and you don't have anything to show. And I think the way to kind of deal with that is just make sure that you are have kind of an efficient way of framing your investigation to make progress, to have discrete steps that drive you towards progress. So just make sure that you set yourself up at the beginning, at the outset of your investigation, to achieve success. So it's like, once you understand the background of the case, like why did they bring you in, figuring out what are the questions that you need to answer with your investigation. What are your objectives? Is it that you need to just kick the attacker out of the environment? Do you need to find out if an employee shared data out? Once you know the questions that need to be answered, your objectives, now figuring out what are the tasks, the forensic tasks that are going to give you a high likelihood of success in achieving answering the question. You may not get the answer that people want, but you're going to do your due diligence to answer that. Is it imaging a full disk image of the drive and then indexing the whole drive and then running a keyword search to see if like forensic appears everywhere? Is it taking a small triage image that just gets a few key artifacts and then parsing those with specific tools like Registry Explorer or When Prefetch View? Is it doing something else, loading it into a big data like a Splunk or an Elk, so you can do these big timeline analysis on a machine? Figure out what you need to do, and then achieving those steps, making sure that you're not just throwing every single thing at the books you have. When Abby showed autopsy, there was a list of ingest modules. There was like there was probably 10 ingest modules there, and in the newer versions of autopsy, there's a scroll bar because it runs off the page. There's like 20 different ingest modules. If you click every single thing and run it because you don't really know what you're doing yet, that will sit there and run for days and days and days and days by the time you're done with a typical laptop, 500 gigs. So you need to kind of know what to do to achieve your objectives. Make sure you have clearly delineated objectives, questions to answer, and then make sure you kind of identify the tasks that you can do to help efficiently drive towards answering those questions.
Perfect, thank you. We have a Sandra who said, "Go Abby."
Thank you, Sandra.
I think it like Abby was saying earlier, how it's important to, like, obviously when you guys are looking at someone's hard drive, you're not kind of going into like folders where there's not anything kind of like hot information. You're checking the user's files first. That way, it kind of could potentially make the process so much shorter. I could feel the pain when Ramon was talking about the 24 gigabyte hard drive, the 12 gigabyte hard drive.
Yeah.
Yeah, that does sound very rough. So I think these kind of procedures you guys take is a huge step in that kind of process. So thank you so much. That is everything. You guys are doing this for free out of the kindness of your hearts, being here on a Saturday morning, all day. So I really appreciate that. You guys are fantastic.
Thank you so much,
I
Michael.
just see one
And
question.
we'll be
Yeah.
sure to see, everybody at the 2:30. I think that question
Yeah.
will fit
Yeah.
perfectly for what is different.
Go ahead.
We'll talk
Perfect.
about
Yeah.
skill
Elsa, if you're
sets,
gonna take the next
certifications.
one. Yep. Elsa, if you're gonna be in the next presentation, that's a perfect one to ask there, and we'll have more time to cover that.
Absolutely. Yeah.
Awesome. So yes, so exactly. So there is another session featuring Ramon and Abigail, and they're wonderful. It is what is DFIR? So that is at 2:30. So we're gonna have like a 15-minute intermission, and check them out there. And feel free to post that question, and they're very eager and ready to answer all your questions. Thanks again, guys. Take care.
Bye.
Okay, so up next we will be having Datagram at 2:30. So if you guys want to, feel free to step away from the computer for now, and you can check out other talks. So next up is going to be, I want to make sure I get the title exactly, Binary Exploitation for Beginners with Datagram. So Datagram, if you're there right now, we can kind of speak and get ready for your presentation at 2:30. And if you're not there, then no worries.
Yeah.
Hey, how are you doing?